This lesson will be about dimensional analysis. Oftentimes, we are given a value expressed in terms of one unit that we want in the form of another unit. For instance, this problem states that riders have to be at least 48 inches tall to ride a roller coaster. What is 48 inches in feet? We are given a value in inches, and we want that value to be written in terms of feet. Dimensional analysis allows us to convert from one unit to another unit if we know a way to relate the two units together. Let's start with what we're given. The quantity we need to convert is 48 inches, so we'll begin by writing down 48 inches. To do the conversion, we need a true equivalent statement between the relationship between the units we start off with and the units we want at the end. This true statement between two units is called a conversion factor. The relationship between inches and feet is that there are 12 inches in 1 foot. Now, the issue is, how do we write down this conversion factor in a way that allows us to solve the problem? One thing we know is that if we have a fraction where the numerator and denominator are equal to each other, for example, 3 over 3, then this fraction is equal to 1. We can write conversion factors as fractions as well. 12 inches over 1 foot. We can also write this as 1 foot over 12 inches. Because 12 inches and 1 foot are equivalent to each other, in a way, you can think of these fractions as being equivalent to 1. The reason why this is important is because we know that multiplying anything by 1 does not change the quantity we have. In our problem, we are not changing the length, we're just changing the units it's expressed in, so we want to multiply by 1, so to speak. So, which of these two conversion factors should we use? In dimensional analysis, units obey the rules of algebra, so units will cancel out if the same unit appears in the numerator of one fraction and the denominator of another fraction. We start off with inches, and we want feet in the end, not inches. So if we use this conversion factor, so times 1 foot over 12 inches, inches are in the denominator here, which will cancel out with inches over here, leaving us with feet, the intended unit. The last thing we need to do is to actually calculate the value in feet. A simple way is to multiply everything across the top, then divide by everything across the bottom. In the calculator, we will input this as 48 times 1 divided by 12, which should result in 4 feet as the answer. Now let's see an example of dimensional analysis applied to the AM6000 concept. How many atoms of aluminum are there in 5 grams of aluminum? Pick the setup that will correctly calculate how many atoms of aluminum there are in 5 grams of aluminum, and then calculate the number of aluminum atoms. Looking at these two setups, we can see that the only difference between the two is in the orientation of the conversion factor. Setup A has grams on the top and atoms on the bottom, whereas setup B has atoms on the top and grams on the bottom. The conversion factors are flipped. To pick the correct setup, we have to pick the one that will result in the units we want at the end, which are atoms. This means that we need to cancel out the units we start off with, which are grams. To do this, we need units of grams in the denominator, so B is the correct choice. Grams will cancel out with grams. The last thing we have to do is to calculate the result. Once again, we multiply everything in the numerators and divide that by everything in the denominators. In this case, it will be 5 times 6,000 divided by 27. and we should get around 1,100 atoms as our answer. Example 3. Earth takes 1 year to orbit the Sun. Use the given conversion factors to calculate how many seconds Earth takes to orbit the Sun. This problem here demonstrates a big benefit to using dimensional analysis. Most of us don't know a way to go directly from years to seconds, but we do know facts like how many days are in a year or how many hours are in a day. Dimensional analysis allows us to line up conversion factors one after the other, enabling us to do multiple conversions at once. I'm going to show you what I mean using this website called Gizmos. This right here is the same problem as example 3. In the top right corner are conversion factors that can be dragged over to the bottom here to calculate the answer. To start, we want to go from years to seconds. We don't know how many seconds are in a year, but one fact we do know about years is that there are 365 days in a year. So I'm going to drag over the tile with that conversion factor. As you can see, if the units are in the right place, they will cancel out as shown by the red lines, and you'll only have 1 unit in the results right here. But if they're in the wrong place, as in if this tile is flipped, then there won't be red cancel lines, and we'll end up with strange looking units in the result. So let me flip this back. Okay, so now years are canceled out, and we're left with days. The units we want at the end is seconds, so we're not quite there yet. We don't know how many seconds are in a day, but we do know that a day has 24 hours, so I'm going to drag in that conversion factor. We know that this conversion factor is in the correct orientation because with days in the denominator, we cancel out days here, and we're left with hours. So we're making some progress. We're not at seconds yet, so we still have to keep adding conversion factors. Is there a conversion factor between hours and seconds? Yes, there is. This tile states that an hour is 3,600 seconds, so I'm going to drag this over. Okay. Is this setup good? No. We can see that seconds and hours do not cancel out, and the current setup leaves us with some strange units over here. So I need to flip this conversion factor. And if I do so, now hours cancel with hours, and we're left with seconds as the only units remaining, and that's the units we want at the end. This website immediately calculated this number right here, so I'm going to show you what to do to get that value. One way you can do this is to multiply all the numbers in the numerators together and divide that by all the numbers in the denominators multiplied together. If you're entering this into your calculator, it's going to look something like this. Parentheses 1 times 365 times 24 times 3,600 close parentheses divided by parentheses 1 times 1 times 1. Now, we don't actually need all these ones right here because we know that multiplying or dividing by 1 doesn't affect our answer, but this is what we would do if we had some other numbers in the denominators right here besides 1s. So, if we calculate this right, we're going to get 31,500,000 seconds as our answer. At the bottom of the first page, you should see a link that will take you to the Gizmos website for more practice with using conversion factors in dimensional analysis. When you get to this page, click on the drop-down box next to the word conversion and select time. You can use the free version for 5 minutes, which is plenty of time to get some good practice before starting on the assignment itself.